All right, so our topic of discussion today is Unit 2.1, and this is day 3. And this is now what we're going to be talking about the vertex form of quadratics. So we're going to still continue on the same path that we have been so far, so that we can at least look at the way that the quadratics work with graphing them and kind of all the forms of quadratics. And so this is just a continuation of that. So what we're going to be referencing today is what we call our vertex form. Now, what the whole idea of a vertex form is that it tells us a lot about our graph, especially as far as what we would consider transformations. And we can transform our function in a particular way by using these values of a, h, and k. And that's going to kind of be the basis of what we're using here. Now, notice that our form is x minus h squared. So the squared gives us the whole idea of a quadratic. Now, from this information, we can peel off a lot of kind of interesting information. And so, first of all, from it being vertex form, one of the first things that it tells us is it tells us the vertex. And our vertex will have the coordinates h, comma, k. So when we look at this, when I look at the vertex, my vertex will be the number from h and the number from k. And we'll talk about how to read that information in just a little bit. Now, when I look at the rest of these variables, each one of these tells me something different. So a, what that can do is, this is what we refer to as a shrink or a stretch. And so we can talk about the transformation that happens. So when we take a and we either increase that value or decrease that value, it makes our graph stretch, or it makes our graph shrink. And when I say shrink or stretch, we'll talk about those later, but it allows me to make my graph either wider or smaller. So we shrink when a is between 0 and 1. That's when it will shrink, and it stretches when a is greater than 1. So the idea there is that we either have 1 or something that's a decimal or a fraction that's less than 1, and then we have something that's greater than 1 to kind of either multiply it by something. Now, the other value that we have that's kind of interest would be k. Now, k is what we would be considering a vertical shift. So with k, this shifts our graph in a vertical direction. It either moves it up or it moves it down. So when k is greater than 0, this is a shift up. So the whole graph will move up. And if a is less than, or k is less than 0, this will shift down. So we can kind of think of those transformations that we used in geometry. Now with h, the easiest way to remember this one would be that this is a horizontal shift. And so when we change this value of h, we will shift either to the left or to the right. Now when h is greater than 0, this will be a shift to the right, because we can think of that we're shifting in a positive direction. And if h is less than 0, we're going to shift to the left. So each one of these values means something as far as some of the transformations that we can go through. So if I was to look at the parent function, I would know exactly where this graph was moved and how it was moved. And then one of the other big pieces of information that it gives me is that it gives me my actual vertex. So the thing that we transform is our vertex. So I tell you the vertex. So if I gave you a graph like this, and I told you this was the vertex, and then I could tell you whether I shifted it horizontally, shifted it vertically, or both, and I said, okay, well now my function is over here, and I shifted it up and to the right. And so that's just kind of what we use our vertex form for. Now, outside of that, with the computational side, we have similarities and differences of our standard form and our vertex form. So first of all, the vertex form tells us our vertex. And with our standard form, what this really only tells us is that this tells us our y-intercept. And that's not a whole lot of information from that. I could still find my vertex in standard form, but remember I have to use the negative b over 2a. But what we'll find out is that our vertex over here is h, comma, k. And so it's already kind of there for us, and so we don't have to necessarily worry about it. We use the standard form, and what we'll know is that this A and this A are going to be exactly the same. That's why I didn't duplicate any variables, because we want those to be exactly identical. So with the vertex form, it's telling me my vertex. With the standard form, it tells me my y-intercept. It can tell me initial values. It can tell me all these other values. It can tell me whether it points up or down. But this also tells me what that does too as well, because this A can still be used as the same A over here by telling me whether this faces up or telling me that this faces down. But in reality, these two forms are identical to each other because we can turn one into the other and vice versa. So I can take a vertex form and give you my standard form, and then I can take my standard form and I can give you my vertex form by actually finding my vertex. And we're actually going to do that today. Now, using vertex form is probably the easiest way to graph because it tells me my vertex already. I don't actually have to do any computation in order to find my vertex. I just use this information. Now, in order to find my vertex, it's a little tricky because we have to think about what the original form of the equation is. And so from my vertex form, remember this is a times x minus h squared plus k. And so what this means is that h in this situation, since it's x plus 1, h is going to be negative 1, because the only way that I could set that up in order to make that work is to use the x minus h, is to make sure that h is negative 1. Now here, k is equal to negative 4. Now that one's going to be exactly what it looks like. It's supposed to be plus k, but it's minus 4, so our k is negative 4. So that means our vertex is negative 1, comma negative 4. And so what I can do, just like I did before, is I can take that vertex and I can plot that on a coordinate plane. And so here's my vertex. I know from that vertex that I have my axis of symmetry. And then so what I'm going to do with this is I need to find a second point, and then I'm going to reflect it across the axis of symmetry. So remember, as we've kind of learned, that axis of symmetry and that vertex go hand in hand. If I can write one, I should be able to find the other. But if I know the vertex, I can immediately write my axis of symmetry. So what I'm going to do is I'm going to pick a value to plug into my original equation, which is x plus 1 squared minus 4. And so what we can do is we can really just pick any value that we want to. I would suggest picking a value that's not too far away from your axis of symmetry because we don't want anything too large that's going to be off the graph. So usually within 1 or 2 distance away from the axis of symmetry should be fine. But also something that's very easy to work with. I like using positive numbers, and let's just say I'm going to use 2. 2 might be off the graph, so maybe I'll choose 1. And so what I'm going to do is I'm going to choose that x equals 1. So I want to use and find an ordered pair for when x equals 1. And so all I'm going to do is I'm just going to plug that into my equation. So 1 plus 1 squared minus 4, and then I'm going to solve that. So 2 times 2 squared minus 4, which is going to give me 2 times 4 minus 4, and that gives me 8 minus 4, which is 4. And so the ordered pair that I would get from that would be 1 comma 4. And so what I can do is, now that I found my second point, this is a situation where it's easier to use the vertex form than it is to use standard form, because now I'm not actually doing 2 things of operations. I'm just doing 1. And so I'm going to go to 1 comma 4, which is right here, and then I'm going to reflect that over the axis of symmetry, which is going to be at 3 comma 4. And then I'm just going to draw my line. And so I draw my curve, and now I have my quadratic. So the idea with the vertex form is it tells us our vertex, we just find a second point, and then we can plot them, reflect them, and then we're done with our graphing. So vertex form does make it a little bit easier to graph. All right, so let's look at another question here. So I have my vertex form, so I just need to find my vertex here, and my vertex is always going to be h comma k. In this situation, h is negative 2 because it's plus 2, and then k is equal to positive 4 because it's plus 4, and then that gives me a vertex of negative 2 comma 4. And just like in the last example, I'm going to go ahead and plot that, so negative 2 comma positive 4. Now I know my graph is going to point downward because this is negative 3, so I should expect something lower than this. Now I just need to find a second point, And so in order for me to find a second point, I'm going to just need to plug something in. I'm going to choose positive 1, so x equals positive 1. The reason that I'm choosing that is just I want something that's really easy to work with, and I don't really have to do a whole lot with in order to figure that out. Now, in some cases, you're going to want to make sure that you use something easy, and now that I think about this, I'm not going to use x equals 1. I'm actually going to use x equals 0. Now, I can look at this and I can see that my values are going to be too large. We don't want to make whatever is inside of this parentheses too large of a number, because when we square it, we're going to go off the graph. So I'm just going to use x equals 0. So I'm going to find the y-intercept, basically. So I'm going to plug that in. So negative 3 times 0 plus 2 squared plus 4. So negative 3 times 2 squared plus 4. That gives me negative 3 times 4 plus 4, which will be negative 12 plus 4, which gives me negative 8, and I'm still kind of off the graph there, but that's okay. And so here I get negative 8, and so when x is 0, y is negative 8, which should be somewhere down in this range right here. This is 7. Actually, I'm a little too far there. So that's 7. We'll call this 8, and then I'm going to reflect it. So I'm only have to make my axis of symmetry first, reflect that across, and it should be right about here, and then I can make my curve, which will then look like this. So the idea behind this is that you don't want to choose values that are too large, so that when you find them, they're not off the graph or anything like that. But the idea with the vertex form, it gives you the vertex, you plot it, plot your axis of symmetry, find a different point, and then reflect it, and that's it. Now the next thing that we're going to do is we're going to convert to standard form. So when I'm giving you vertex form, what we want to do is we want to convert this to standard form. And so really what I'm going to do is I'm just going to, my first step is to FOIL, and then my second step is to simplify. And when I simplify, we just have to make sure that we have this in standard form of a polynomial, which is exactly what we're doing. So in order to FOIL this, the first thing that I need to do is I need to expand this. So this is x plus 2 times x plus 2 plus 4. And so what I'm going to do is I'm only going to work with this first, so I need to do my order of operations. So negative 3, and I'm going to FOIL that, which gives me x squared plus 4x plus 4. Now that we know how to factor, hopefully you're seeing the similarities here, that we're going to take these two factors, multiply them together, and then add them together, and then add 4 at the end. Distribute my negative 3, and so negative 3x squared minus 12x minus 12, and then plus 4 at the end, and then combine my like terms, which would be negative 3x squared minus 12x, and then minus 8. So the idea of converting to standard form is really easy. All we have to do is just FOIL the quadratic and then just simplify it after we're done. And so what this will tell me is that this will tell me that c is equal to negative 8. So I have a y-intercept at 0, negative 8. Alright, so I can do the same thing with another example here. We're just going to FOIL, and then we're going to simplify. So I'm going to expand this first. So 2 times x minus 7 times x minus 7 minus 1. That gives me 2 in parentheses x squared minus 14x plus 49 minus 1. Because when I FOIL that out, I get negative 14x plus 49. Distribute my 2. 2x squared minus 28x plus 98 minus 1. And that gives me 2x squared minus 28x plus 97. So it's not necessarily the easiest thing to do, but it is pretty straightforward to convert from vertex form to standard form. So you can at least know those things, and you can kind of identify other pieces to this. Now if I wanted to, I could do negative b over 2a, and guess what I would find? I would find that I have a vertex here of 7, negative 1. And so the idea is that we can still use the same information to find the same stuff that we use the vertex form for. Now, converting to vertex form is a little bit trickier, but the idea is what we're going to do is, the first step is we're going to identify A, B, and C. The second thing that we're going to do is we're going to find our vertex. using x equals negative b over 2a. So just like we did before, we're going to find our vertex, and then we're going to plug it into the original equation so that we can do that. And then finally, 3, we're going to substitute values back into our equation so that we can make our vertex form. Now if I remind you, the vertex form is y equals a times x minus h squared plus k. And so I'm just trying to find that vertex, find h and k that I'm going to get from that vertex, and then use that to create my form. Alright, so a, b, and c. So when I identify these, a is 2, b is 10, and c is going to be 7. And so the idea behind this is that I'm going to use x equals negative b over 2a. And so I'm just going to substitute those in. So the x coordinate of my vertex is negative 10 over 2 times 2. In this case, that gives me x equals negative 10 over 4, which is going to give me a very non-pleasant value of negative 5 over 2. Which is okay. I can still work with that. It's not really going to be a big problem. And so what I'm going to do with this now is that I'm going to plug this into my original equation. So 2 times negative 5 over 2 squared plus 10 times negative 5 over 2, and then plus 7. So I'm going to go ahead and calculate that, which ends up giving me a value of y equals negative 11 over 2. And so the idea behind that is that tells me my vertex. And so the vertex that I have is going to be negative 5 over 2 and negative 11 over 2. Now I know that these are not nice numbers to look at, but really this is only just 3.5, and then this is 5.5. So it's not really anything too crazy, but we can't expect to have perfect values every single time. And so from this, now that I have my vertex, all I have to do is just substitute those values into my vertex equation. So my vertex equation is going to be y equals, I'm going to use the same value of a that I started with, so this is going to be 2 on the outside, multiplied by x minus negative 5 over 2, because that's going to be my h. Remember, my vertex is h comma k, squared, plus negative 11 over 2. Now I can simplify that by just kind of using my basic methods, and that's what gives me the y equals 2 times x plus 5 over 2 squared minus 11 over 2. So we can kind of see where we get that idea of when we take the negative with whether h is negative or h is positive, whether that's plus or minus. So we're kind of always taking the opposite of that in a way. But the idea is that this is my final value here. This is my vertex form. So I can easily find my vertex form by just using the x equals negative b over 2a, plugging it back in, and getting an x and y pair to find my vertex. Alright, so here's another example here. Now again, we're just going to identify a, b, and c. I'm going to do that over here. So negative 2, positive 8, and positive 3. Now with the vertex, again, we're just going to use x equals negative b over 2a. Now if I do that, I can do that up here. So x equals negative b, which is negative 8, over 2 times negative 2, which gives me negative 8 over negative 4, which gives me a much easier value to work with in positive 2. Now I take that positive 2, plug it in everywhere that I see x, and so I have y equals negative 2 times 2 squared plus 8 times 2 plus 3. I can go ahead and simplify that. So negative 2 times 4 plus 16 plus 3, and then I can get a final value of y equals 11. So what that means for me is that my vertex is positive 2 comma 11, and so I can use that vertex, which stands for h and k. So a, which stays the same as negative 2, h is going to be positive 2, and k is going to be 11. So when I plug that in, my vertex form, remember, is y equals a times x minus h squared plus k. So when I plug those values in, I get y equals negative 2, because that was my a, times x minus 2 squared, and then plus 11. So the idea is I can convert to vertex form simply by finding the vertex and just plugging in my values and using my a as well. And so that's going to do it for this video of using our vertex form and how we can manipulate with our vertex form.